downloads. Okay, let's record. Okay, let me grab this link. Copy. I'm gonna put it in the chat. Okay. Oh wait, we haven't looked at how to do it in Excel yet, have we? Like the cheater way? Oh, let's do the cheater way. Okay, let me show you the cheater way to do math like this. And I'm gonna first, some of you may already have seen this, and so you can just chill and be fabulous and learn with everyone else. So everybody, I'm gonna delete all this, and I'm gonna show you how to do this. I'm gonna show you how to use Excel to do your math for you, which is beautiful. So let's see. Oh, it's very exciting there. Let's see. Lukey, I'm going to mute you real quick because people are chatting in the background. All right, cool. All right, so you should see this, okay? And so you can make a copy of this, or you can just watch me do it, but then do it. But so let's see. So when we did this, we said, all right, we're going to make a timeline that is 200 either slides or toilet paper sheets long, okay? And so I had some people did this. eBlock is a little bit ahead of y'all, so they did this. Let me show you what this looks like if it's a Google slideshow, because you're going to make this timeline. Okay, so what they did is they said, okay, I'm going to make a timeline that's 200 slides long. Okay, and the very first thing that happens in 200 slides, which counts for 4.6 billion years, is the Earth forms. You can't have anything happening on the Earth if the Earth isn't there, right? So the Earth has to form. So when we did this, we said, all right, so 200 sheets is the same as 4.6 billion years, okay? So that was number one. Cool. But then how do I figure out the rest of it? And I showed you a ratio where you said if 200 sheets is 4.6 billion years, but I don't have 4.6 billion, I have 3.8, then you put X over whatever that age is, and then you solve for X, right? Do we have questions? Nope. Okay. Excellent. Which if you did it that way, beautiful, fabulous, because I told you to do it that way. Now let me show you the way like math teachers do when they're like, now let me show you how to do it in your calculator so that you don't have to do it that way. Why do we do it this way? Because it's good for your brain to do these things and to learn patterns. And oh yeah, you can, absolutely. You also get to learn how to use Excel, which is something you use in college a lot. When I got to college 1,000 years ago and they were like, you don't know how to use sheets? I was like, hey, be quiet. I went to public school. And they're like, well, this will save your life. Here you go. Let me show you how to do it. All right. So I'm going to add a column here. I'm going to insert one column to the right. Nope. To the left. Whoop. So see, I went up here. I hit this little triangle. Fabulous. Okay. And now I'm going to say, okay, so my equation, I'm going to put an equal sign for equation. Very important. Equals is equation. Now, if you put an equal sign, that automatically tells your sheet, hey, this is an equation. Please solve it. Boom, it solved it because I put the equal sign. But if I don't put the equal sign and I just put 5 plus 4, it doesn't do anything. As soon as I put that equal sign in front of it, boom, it solves it. Cool. So if I rearrange this equation so that it's I'm solving for X, then it's 200 times whatever the age is, which is here. So if I say, okay, so it's 200 times the age, cool, and then divided by 4.6. What, Miss Noel, this doesn't even work. You're stupid. No. If there's any writing in the cell, it won't see it as a number. In order for it to see it as a number, you can only have numbers. So if I put 4.6 right here, and then okay, right, because there we go. And I say, hey, actually the age is this one. Oh, look at that. Oh, Miss Noel, it's 200. Oh, I know, but you know what? Let's do it for the next one. So this is 3.8. I want to use okay, hello. There we go. Okay. Let me do this right. There we go. So I've already put the formula in. So see how it makes a little box right here? That like, here's a little box. I'm going to pull it down. Boom, it solved it for me. Beautiful. Oh, yeah. Right. Exactly. You don't have to redo it. This is a nice thing to learn, but you don't have to redo it. Okay. So now I'm just going to go straight down. Okay. 2.7, 2.3. Uh-oh. Now I'm not in billions. Oh yeah. Olivia, go for it.
I'm just confused why you would multiply it by 200.
Oh, because that's what we said. Like originally this was done in toilet paper and you're using 200 sheets of toilet paper.
Okay. So you do 200 multiply. Okay. Could you put this recording on?
That sounds like the biggest waste of paper ever.
Yeah, that's why I also gave the option to do it in Google Slides instead. Exactly right. Yep. Yeah, I'll post this. It's recording. Yeah, all good. Okay, so now, but wait. Oh no, this isn't in billions of years. This is in millions of years. But I took out the MYA. So remember, to go from millions to billions, you have to divide by 1,000. Cool. Now I'm just going to go straight down and make it do that to all of them. So I'm going to pull it all the way down. Boom. And now I'm going to do the same thing with this. I'm going to pull this all the way down, and it's going to do the math for me in 3 seconds instead of the entire night where I made you do it by hand.
How do you do that? I don't get that.
Yeah. Let me show you. Okay, so originally I put in the very first formula. So when I wrote this by hand, it was, where's my iPad? Let me show you how we did it by hand. And here we go. Okay. Pew. Share. Whiteboard. Yes. So originally we said, okay, we have to deal with 4.6 billion years of history. 4.6 billion years. And I'm going to use 200 slides or 200 sheets of toilet paper. One person did do it in toilet paper. I'll show you that picture. So that's going to be 200 years. Or sorry, 200 sheets. Okay, cool. But on other ones, I don't have 4.6. I'm not dealing with 4.6 billion years. I'm dealing with whatever, like 3.8 billion years. Okay, so 3.8. And I need to know how many sheets that equals. So I just make it a nice ratio. And then when I cross multiply, I'm going to get rid of units because I'm a bad math teacher. It's fine. Science knows what it's doing. So I get 200 times 3.8, which remember, that's the age, equals 4.6x. I'm going to divide both sides by 4.6. I get x is 200 times the age, 3.8, divided by 4.6. And that's what I put into the Google sheet. Was I said, okay, x is going to equal 200 times age. And you have to use the asterisks for times in Excel. Or in Sheets. I don't know why. And then I'm going to do this. I select the age cell. Why is it called a cell? It's not a cell. It is. A cell just means a little contained spot. And then divide by 4.6. Whoop. Age. Okay, I'm going to take a picture of this. I'll include it with the recording. All right. Oh, I can hear a hawk outside, y'all. Very exciting. So that's exactly what I put into this sheet. Was I put 200 times, and then I click the age box. So I know, hey, whatever the age is, I want it to use that. And then divide by 4.6, because that's my equation. How we doing? Nobody's crying. Excellent. And then I just dragged it on down. So by putting in the equation here, see how it says, well, that's C4. Well, then I pulled it down. Oh, now it says C5. Oh, now it says C7. Oh, it pulled it down. What? There's no way to teach us this first so that we could do this the whole time. I know, I'm very mean, y'all. I'm very mean. And you'll see the places where there's two things, like the age of fishes and then the age of fishes, I put the start and the end so that I could say, okay, it starts at 415 million years ago. That's sheet 18. And it ends on sheet 15 at 335. Okay.
My ADHD is a little confused. Do you think you could put this on my Jag?
Oh, absolutely. Yeah, 100%. Yeah. Because now that I have the sheet number, I can just go and make my timeline. So I said, okay, cool. Number. And if you want to just copy this document and use this document, use this document. Okay. It's all set now. Just copy it as it is now. Use it. I don't care. It's fine. I will assume you've done the math, and that's fine. Don't tell your math teacher. Now I'm going to go and I'm going to make a timeline. So you could do it in Sheets. Okay. You can make your, sorry, not Sheets. You can do it in Google Slides. I also had someone who literally did it on toilet paper. And they realized that, oh, hey, this is really big now. What is happening? And so in order to take a picture of it to show me, so this is sideways, but he can see the Earth forms here, and then, oh, it has to be reconnected here. It was just too long. And then there's a little more. Okay. I know it is sideways. I can't figure out how to make it not sideways when it's doing this. And so, but you can see, like, the point of this assignment is to make you see that there's huge gaps in the history of the Earth where just nothing happens. So, like, if you look from 4.6 billion years ago, the Earth formed, and it formed out of the spinning of all the stuff that was coming together to make the sun. If you take astronomy, I go into much better detail than that. And so everything's spinning, and then, like, like when you spin a pizza dough, I don't know if you've ever spun or watched someone spin pizza dough, they throw it in the air, it gets really flat. So, like, basically the Earth is like made out of the crust of a pizza dough. Each planet is like its own crust that all came together. The asteroid belt between Mars and Jupiter is where a planet did not come together because Jupiter was too big and it pulled that planet apart, so it could never actually form. So that's exciting. Okay, so then you see the Earth forms, and then the next thing doesn't happen until slide 165. That's so far. Keep going, keep going. The first prokaryotes. Now, remember that prokaryotes, I'm just going to write on Nix because I want to. Well, this is 3.8 billion years ago. These are your bacteria. This is the very first life on Earth. The Mars rover that's on Mars now, the new one, Perseverance, which they call Percy for short because scientists don't know how to spell. I'm an example of this. So they don't know how to spell Perseverance, so they just use Percy, and I think that's adorable. This was the very first form of life on Earth. So the Perseverance on Mars is looking for bacteria, because if there's bacteria, then it could show that either life exists on Mars, or maybe it started and then it failed for whatever reason. Okay. Because we see that so the next big thing that happens doesn't happen until oh my God, another billion years goes by before enough bacteria have colonized the Earth that they start, that some of them start eating each other. So this is cells with a nucleus. I can't see what I'm writing, so I don't know if I'm spelling it right. Nucleus. So what happens with cells with a nucleus is usually they steal stuff from other cells. So like our mitochondria is just a bacteria cell that got absorbed by a eukaryote, and it was like, I'm going to use you now. Ha ha, sucker. Make some power for me. And that's all the mitochondria does. It actually does a little bit more. So mitochondria has its very own DNA. It only gets passed down from mother to child because a sperm is not big enough to have mitochondria in it. It's literally just the nucleus of a cell. And so the egg has to carry that mitochondria. And the mitochondria, basically all the mitochondria does is it makes you energy through ATP, and it makes your steroids. Okay. So it's very important. Like if we didn't have steroids, who knows what would have happened to we might not exist. Yeah. Yes. Okay. Do it. I believe in you. Okay. So after the cells with the nucleus are happening, okay, so that means, by the way, we don't know when it started happening, but some of these organisms started breathing, they are all breathing carbon dioxide, and they breathe so much carbon dioxide that oxygen poisons the atmosphere. Eventually poisons most bacteria. Oh no. So we get our first mass extinction. First mass extinction. And it's all because we had these cells that were doing so much photosynthesis that they pulled so much carbon dioxide out of the air. And by the way, if you pull carbon dioxide out of the air, you get an ice age. Also, so much carbon dioxide. You don't have to write these details in your slideshow, but you can if you want to, because it's just fun. So much carbon dioxide leaves atmosphere that we get an ice age. Interesting. So it isn't so much a climate change that caused the extinction in this case, it's just poisoning the air. Oh Oh no, guess what report just came out recently? It said that many deaths, probably close to 500 million deaths a year, are attributed to fossil fuel burning. Oh no. And it's all because, oh no, it turns out breathing bad air is very bad for you. Who would have thought? Oh no, everybody. Oops. Okay. How we doing, y'all? Are we liking this fun talk while you make your slides? Or are we smiling and nodding? Okay, good. I'm down with that. All right, cool. So let's see what the next thing. So this happened. When did this happen? Oxygen happened. That's number 4. It happened 2.3 billion years ago. So see how there's a huge gap? Like it doesn't seem like a big gap to go from 4.6 to 3.8, but that's billions of years, y'all. So long. So if we go and we look at this, the toilet paper, if we zoom in a little bit, you can see that, okay, so here's where the Earth forms. There's the first prokaryote. The first eukaryote has a huge gap. And then as soon as that, there's oxygen. And then look, it takes so long for the next thing to happen. And then suddenly things happen really fast, which is weird, but that's just how evolution works. And part of it is that we only know this from fossils. All of this evidence is coming to us from fossils. And it turns out things that are squishy don't fossilize very well. Uh-oh. So here we go. Oh, did I miss it? Let's see. No, I did not. Oxygen. Boop, 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 ba, ba, ba. Keep going. Oh my God, so many slides. Oh, so many billions of years for life to come back. So it's a good thing that life didn't just end when oxygen accumulated in the atmosphere. By the way, our atmosphere is 20% oxygen, and almost all of that came from the algae and bacteria that lived on the Earth first. So that's a lot of poisonous gas. So I talked about this in biology, and they're like, wait, is oxygen poisonous to us? And it kind of is. You can't live in an environment that's pure oxygen. It will be on fire all the time. Also, they've tried with like scuba divers and astronauts to give them pure oxygen gas. It will kill you. Okay. So even if you're at a high altitude, you have to go to an oxygen bar. That oxygen is still like 20%, not 100%. Okay. For some reason, we can't survive with too much oxygen. We also can't survive with too little oxygen. Blah, why? I don't know. But for some reason, at some point in history, we see these giant bugs that are like literally these like insects that are this big that survived because there was a lot of oxygen. We just can't do it. Interesting. So it takes a long time for life to rebound from oxygen killing everything. Oh, there is someone who says there's a hypothesis that oxygen kills us. It just takes between 70 and 100 years. So like aging happens in our, like a lot of times oh yeah, go for it, Olivia.
A few things. I heard about that
please.
theory that like we might have like died. Like people say, oh, what if we moved to a different planet? And because the whole theory that it kills us in 70 to 100 years. And also I have to go. Could you send me the recording?
Yes, absolutely. Yeah, interesting. Yeah, I'll follow up on that. Yeah.
Thank you. Maybe we could do a class or a club or something about it.
Yeah. We're talking about that. Love it. Like,
where would this recording be? My Jag or you?
I'll send you an email.
Okay, thank you so much.
You're welcome. Bye. Okay. Then. Okay. So the idea, so like free radical, so we all know we're supposed to eat foods that are high in antioxidants like blueberries and spinach and whatever. What is an antioxidant? It's something that fights oxygen. So when oxygen is together as O2, we love it. It binds to our hemoglobin and it goes into our mitochondria and it makes energy. But when oxygen is by itself as just O, it's very destructive and it can break things up. Okay. So that's part of why, like, oops, oxygen is bad for us. Oh no. Okay, so then what happens next? Finally, we get multicellular organisms. We haven't even had multicellular organisms. They happened in the last 600 million years. So that's 0.6 billion. That's 4 billion years after the Earth forms. 4 billion. So that's 600 million years ago. 4 billion years after the Earth forms. That's insane. So even if we find bacteria on Mars, that's a sign of life. Like people ask, oh, Miss Noel, do you think there's aliens? Do you think there's life out there places in the universe? There should be. Like statistically, the chance of life happening is very small, but the universe is much bigger than that is small. So statistically, there's life somewhere else in the universe. However, it might just be bacteria, which is sad and boring. Exciting, but boring. All right, cool. So we get our first multicellular organisms. Whoops. That means we're talking like coral. So coral is the simplest multicellular organism. So not coral, sponges. So you think SpongeBob, okay? So I had someone in one of my classes be like, what? What do you mean sponges? Like SpongeBob? But there is actually an animal that is called, this is SpongeBob sponge. There is an animal called the sponge that sponges actually came from originally, and they look like this. Now, this may look very complicated, but it's actually a very simple organism. It's just a whole bunch of cells hanging out together. So a lot of people say, maybe it's not even multicellular. Maybe it's just one cell that it's like a colony that works together, like ants. But we don't like to talk too much about it. So yeah. Hi. Hello. Yeah, okay, sponges, very cool. By the way, if you're ever diving and you see an orange or a red sponge, don't touch it. It can probably kill you. Because in the ocean, if it's red or orange, it's called fire or something, and that is a warning color to say, don't touch me, I'll kill you, which we also see on land too, so that's fun. Oh, by the way, y'all, I had a very interesting conversation with one student in another class who said, but wait, in Judaic studies, we learned that the earth formed 7,000 years ago, and then everything started. So what should we take away from that? Is that wrong? Is that right? What's the difference between our geological history and the real history? Not real history, Judaic history. What do we think? Think about when was that when was the Torah written? Was science legit? No, yeah. So when the Torah was written, people were doing their best, but they were recording a history of people. So the Torah is talking about a history of people. Okay, so that is the history of the Jewish people, which, the recorded history started like 7,000 years ago or whatever, right? And so that's not unright. It's just not scientifically right. So it can be complicated, but you can't have those two ideas in your head if you are ascribing to the Jewish studies interpretation of the world, and still also believe in the scientific side of it as well, or one or the other. But to pass this class, you have to believe in science. No big deal, just a requirement. I saw a meme or a tweet that said, oh, in high school, if you don't believe in science, it's just called failing. Which, hello. Okay. All right. So we get our first multicellular organisms. And then, so remember, it took billions of years for this to happen. And then boom, stuff starts happening. What? We get fish, we get plants. Now let's talk about some of the ancient fish, y'all, because they were weird. If we talk about, so this was the Devonian era. Fish. And we know about these fish because they started having hard parts. They had parts of them were hard that would fossilize, which made it much easier to find them. Okay, so we have, I love some of these fish because they look super bananas. Like, what's this? We don't know, but it's an ancient fish. We found a fossil that's got these weird plates and then a weird unicorn tooth. And then what? Amazing. Some of my favorites are the Dunklosaur. Look at this guy. He could bite your whole face off. He's eating a shark. Oh my gosh, y'all. We have just the weirdest teeth you'll ever see, unless you look at the shark.
I have a Dunklosaur fossil in my game.
Do you really? Cool. Oh, I love that Animal Crossing includes that. So let's look at, there is a weirdo shark. Helico that we only know from one fossil because it's the only thing that fossilized, and it's this weird world. So it's a weird world, and we don't know, how did that world exist? Was it like this? Was it like that? We don't know. All we know is the fossil. So people are trying to be like, well, maybe it was like this, maybe it was like this. We have no idea because all we have is the one fossil. And that's why I couldn't do paleontology, because I was like, we literally only have one fossil of this, and we're trying to base an entire animal off of this. I can't deal with this. And that's why I teach instead. But the thought is because modern sharks, their teeth grow out in a whorl like this. They just stop at the lip. It could be that that's what's happening with Helicoprion, is that the teeth came out and then they just kept spinning around underneath. Now, obviously, this wasn't successful, and the modern shark is more successful, or else we would still see this animal. I'm going to end this so I don't have to keep looking at my chin. Boop, boop. Okay. So before the, okay, here's the fossil. Look at this. It's very exciting. It's obviously a very large animal. Like these teeth are already bigger than great white teeth. But what is it doing? We don't know. We don't know. There is if you were in the marine biology class, by the way, we talked a little bit about this. There is something called the fringe shark. Fringe shark? Fringe shark? I think it's the frilled shark. Frilled shark? Let's see. Yeah, that's not a thing. Oh, there we go. And its teeth look like that, but on a small scale. So you can see their teeth each have a little bit of a bloop pattern coming out, but they again stop at the lip like modern sharks do. And they are smaller. They're much smaller. Okay. Is a frill shark in Animal Crossing? I must know.
Frill shark.
Have you seen it in Animal Crossing?
If I haven't seen it, if it's, I don't know, but if it hasn't come out yet, it's because it's not the right month.
Gotcha. Excellent.
But I did catch a cute. But I did catch a coelacanth.
Coelacanth. Oh, coelacanths are very bananas. So coelacanths.
It's like the rarest fish in the game, and I got it on my first try.
Nice, nice. Yeah. So coelacanths.
There is no frilled shark, I believe.
Okay, good. That makes sense because they're
What
kind of.
What do they have? They have hammerhead shark, saw shark, whale shark.
Nice. Love them. Oh, I love saw sharks.
And they have the great white shark, and that's pretty much it.
That one's very complicated.
And saw shark. I said that.
Yeah, I love saw shark. Okay.
And they have a shark tooth fossil, which I already got.
Ooh, cool. Like the megalodon. Oh, cool. So the coelacanth, some people say that, the coelacanth is called a fossil fish because for a long time people are like, okay, it looks a lot like those ancient fish we saw in the Devonian era. Okay, it's got the same kind of body plan as those fish. We haven't seen one of its fossils for a really long time. We just assume it's dead because it looks like one of these fish and we don't see fish like that anymore. And then some white people went to Africa, an African market, and saw the coelacanth. And like people were eating it, they were selling it in a fish market, and they're like, "Oh my God, we discovered the coelacanth!" And all the people there were like, "No, you didn't. We've been eating this our entire history." And they're like, "No, we discovered it because we're white. We get to claim it." So for a long time, there's been controversy. There's a lot of issues when people discover species. Like, did you discover it or are you just appropriating native culture, which is a little bit about what's happening here. But people do like to use the coelacanth as an example of, oh, if this fish that looks like an ancient fish, and we didn't even know it existed, even though people did, if this still exists, then maybe the Loch Ness Monster is real, which is a little bit of a jump in logic, but whatever. People like to believe what they like to believe. Okay. We kind of skip over, I think, let's see, let me go back to this. Oh yeah, so first organisms with hard parts. So that's very important because let's see. So first hard parts fossils. Because that's going to be stuff that is not like fish. That's going to be your stuff that's like the ammonites. So those are like modern squid, but squished up in like a little circle square or a little circle fossil. Those I'm sure. The nautilus is probably in. So the modern version of an ammonite is the nautilus, which by the way, I didn't realize was still a living animal until I saw it in an actual aquarium once. I was like, it blew my mind. But yeah, these guys are alive. They look a lot like the fossil ammonites. They're basically a squid squished up in a shell because squid and octopus are just very fancy snails. They're related to snails. They're very fancy snails. Which is kind of a weird thing to think that a cuttlefish just passed a test that 3-year-old humans take for intelligence, and a cuttlefish passed this test easily. So wait, these animals that are literally as smart as a human child are related to snails? Yes, they are. Right? So so why haven't they taken over the world if they're really smart? Oh, because when they mate, they die, which is a very bad evolutionary strategy. You don't go very far when you die after mating. Imagine if humans died after mating, we never would have invented fossil fuels. Okay, I think that's as much as I want to do today. I want y'all to have time to work on your timelines. Okay, so decide how you want to do it. Do you want it to be toilet paper? If you're at school, you could go and get paper and tape it together if you want, and then like, I don't know, put it on your wall one day. Include pictures. Just make sure you include all of the slides or sheets that are in between, even if nothing is happening. Because remember, part of this is to see how nothing happens for a really long time. And it's not until something epic happens that we see change. And that's going to be something very important when it comes to thinking about climate change in our modern era. Okay. So, does anybody have any questions? What I want you to do is work on your timelines. And Wednesday is our next class, but it's a mental health day. And then we don't have class next Monday. So I won't see you all again for a very long time, but I will see you at Shabbaton. Oh, due. When is it due? Let's say it's due after Shabbaton, but before spring break. So let's just say before spring break. Yeah. Before spring break. And we'll talk about this again next week because so much stuff is going on today and this weekend that like if you end up forgetting about this, it's fine because you can still do it before spring break because like some of y'all are on campus and it's very overstimulating, I'm sure. Some of you like, hello, Shabbaton is happening this weekend and you've never gone to one of those. And so that's bananas. And we'll talk about this again after Shabbaton so that you don't have to worry too much about it. Okay. All right.
Thank
I
you,
will
Miss
see y'all
Noel.
in a million years.
Thank you.
Bye, everybody.
I have a question. really
Yes,
quick.
hello.
So if it's sorry, it's loud, but if it's like 0.07,
Yes.
is that go like on slide 1?
Yes.
Like,
Mhm. Yeah.
okay. And then also if it's like the start and end ones, like if it's like 3 and 0, would it go on 3?
Yeah, 3, and then like you can put the end of it on 0 also.
Okay.
Yeah.
Okay, cool.
Good
Thank
question.
you.
Bye.
Miss
Hi, David.
Noel,
Hi.
I just had a quick question.
Yeah.
So for each one, all we're doing is just basically like we're writing all down all of the times and then basically what happens during that
Yes,
time.
exactly right. You can even just copy and paste it over.
Okay, and does it have to be like specific? Like, let's say there's like multiple things. Should we just mention one or both?
Oh no, put them all on. Mhm.
Oh, okay.
Yeah.
All right. Thank you, Miss Noel.
You're welcome. Bye.